right, today we're going to start solving systems of equations, all right? So here's what a system of equations looks like. You have two different equations. You got x's, you got y's, and you're going to have to figure out an x and a y that works for both of the equations. So one way you can do that is by graphing the lines and seeing where they cross each other. So this first example, we have y equals 2x minus 3 and y equals x minus 1. We're going to graph them on the same graph, and we're going to see where they cross each other. So this first one, y equals 2x minus 3. Remember, your y-intercept is negative 3, so that's where you begin when you're graphing. So you go down 3, and you make yourself a dot. We only need 2 dots to make a line, especially if you have a straight edge. But you can also just keep counting with the slope. So the slope is 2, which again means you're going up 2, over to the right 1. So from that point, we can go up 2, over 1. Now I can't use a straight edge on the board here, so I can keep going up 2, over 1, up 2, over 1, up 2, over 1, up 2, over 1. Heck, we could even go up 2 over 1, maybe up 2 over 1. Now, if we wanted to go backwards, we could go down 2 and left 1. That is another way that we can get some points on there. Let me move this out of the way. You scooch over here. Hey, there we go. Stay right over there. Down 2, over 1. We're going to try to make this as straight as we can. Wow, that is rough. All right, now we try the second one. We have y equals x minus 1. So the y-intercept is negative 1. So we go down 1. We make a dot. Now the slope is right here. And the slope in this case is 1 because there's nothing written there, so there's an invisible 1. Did you see it? It was invisible. So we can go up 1, over 1, up 1, over 1, up 1, over 1. Hey, that's where they cross each other. But let's make our line a little better than the last one. Keep going up 1, over 1. We can go back, down 1, left 1 as well. All right, let's see. Here we go. Oh, yeah! Now we are looking again for the place that they cross each other, which is this coordinate right here. And that coordinate is 2 to the right and 1 up. So the coordinate is 2, 1. We always write our answer as a coordinate, which again, the answer is, where would these two lines cross each other? Now, these are nice because you can test that coordinate and make sure that it works. So if we put those in 2 and 1, remember 2 is our x, 1 is the y. If we substitute those back into the original equation, it says, let me move this video down here. So the first one says y equals 2x, and x is 2, minus 3. 2 times 2 is 4, minus 3 is 1. So you end up with 1 equals 1. Fantastic. You can check the second equation. Y, which is 1, equals x minus 1. 2 minus 1 is 1. Both of them work out. That's why I love these systems of equations. You can always check them in the original equation. It's so much fun.